Hello dear students, welcome back to Pen and Paper Chemistry. We will continue with the topic of carboxylic acids, and we've been speaking about acidic character, and this is video number 2 in the series. So make sure that you have your pen and paper ready. In the last video, I introduced you to the concept of the equilibrium constant of a weak acid, and we also spoke about and we discussed what does the Ka value of an acid tell us about. Now we also said that these are all exponential values which are a little tedious and a little difficult to compare, it takes a longer time. So I was saying that why not convert it into some pure numbers so that we can deal and compare the acidic strength of various compounds in an easy way. So let us take the natural logarithm of the equilibrium constant of a weak acid. So logarithm to the base of 10. You can use your calculators, you can use the log tables, whatever suits you. By the way, logarithm, in case you are not conversant with the topic, is already dealt with on the channel as a separate set of videos. So for now, just substitute the value using your calculator and give me the log Ka values. Would you like to give me the values? Okay. I wish we were having a live lesson and I could take your inputs. It's so much fun and it's so much more interesting to teach that way. So these are the values that I have gotten after substituting these values in the calculator. Now again, if you see, these are negative values. Why not take them as positive values? So the next step we are going to do is we are going to take the negative logarithm of Ka. So negative value of this would be, simply put, 3.75, 4.75 and 2.58. Now if I have to compare the acidic strength, now see here, we said that formic acid or methanoic acid is 10 times more acidic than ethanoic acid. Now look at the negative log of Ka values. Here, when you are taking the negative log of Ka for the Ka value, that's actually lower. So this is 3.75 and this is 4.75, a total difference of 1. So I end up here with a +1, meaning to say, with every exponential or with every multiple of 10, we end up with a +1 value in the negative log of Ka. Now this negative log of Ka to the base 10 is a little difficult to say every time I have to say it. So what we do is we call it as pKa. You remember studying about pH. What is pH? pH, we said, is the negative log of hydrogen ion concentration to the base 10, or it is the negative power to which 10 must be raised in order to express the hydrogen ion concentration. So in the same way, we will define pKa, negative log of Ka to the base 10, or the negative power to which we must raise 10 in order to express the equilibrium constant of a weak acid. So we are again going to base our learning on our previous knowledge. Going back to again negative log of Ka. So what we will do is, okay, now let me get rid of all of this to make things a little bit easier. So this becomes negative log of Ka to the base 10, which is also more preferably written as pKa, a small p, capital K with a small a at the foot, pKa. Higher the value of pKa, lower the acidic strength. Whereas when it was the Ka, higher Ka, higher acidic strength. Whereas when we have pKa, higher pKa, lower acidic strength. Does that make things clear? See here, we said acetic acid. Methanoic acid is greater than ethanoic acid. Look at the pKa values. pKa value of methanoic acid is lower than the pKa value of ethanoic acid. Okay, let's compare acetic acid and fluoroacetic acid. Tell me which is a stronger acid, 4.75 or 2.58? Yes, absolutely. Lower the value, higher the acidic strength. If you want to go into the finer mathematical aspect of it, but if you, okay, first thing is, if you understood this, simply remember, higher pKa, lower acidic strength, lower pKa, more acidic strength. Whereas for Ka, it is higher Ka, higher acidic strength. So, just like we compared, so pKa of ethanoic acid is 1 plus pKa of methanoic acid. In other words, for every 10 units increase in Ka, there is 1 unit increase in pKa. But if you are not very comfortable with the mathematical aspect of it, just forget this. As long as you have understood this logic, it's absolutely fine to go ahead with the topic. To make things easily recallable, I have written over here lower pKa, stronger acid, lower Ka, weaker acid. Please make a note of this in block so that you are able to remember and apply this knowledge for further questions. I'm going to leave the screen on so that you can take down these notes for offline reference. I will also be in a few days, not right away, posting these same notes to Pen and Paper Chemistry Google site. Pen and Paper Chemistry Google site. Earlier it was on Learning Chemistry is Easy and Fun. It's now moved on to Pen and Paper Chemistry site. Also, what is pKa, the definition as well as the application of it. Yes, so it is the negative power to which 10 must be raised, or what is pKa, you can also define it as negative log of equilibrium constant of a weak acid to the base 10. So you need to complete the definition over here. Have you got the notes in place? In the next video, we are going to talk about the effects of various groups on the acidity, and this we are going to determine, and we are going to talk about it with respect to our observations rather than just memorizing the theory bit of it. We will apply our knowledge based on what we have learned so far. So stay tuned, stay connected, and join in the next lesson with your pen and paper. See you soon.